Dear learners, Assalamu alaikum. I cordially invite all of you to today's class activities. Our today's topic is radical equation part 1. Points of learning. At the end of this class, you all will be able to 1. Describe radical and radical equations. 2. Know the procedure of solving radical equations. 3. Solve some radical equations. Main speech on the topic, radical. The word radical in mathematics means any root, such as square root, cube root, fourth root, etc., and is generally denoted by the symbol nth root, where n is any integral number greater than 1. Radical equation. A radical equation is an equation in which at least one variable expression is stuck inside a radical. As for an example, square root of x minus 4 plus 2 is equal to square root of x plus 12 is a radical equation. Since one radical on the right side of this equation is isolated, that's why such equation is also called an isolated radical equation. Procedure of solving a radical equation containing at most 3 terms. Step 1. Isolate one radical on one side of the equation if necessary. In order to make it clear, let us consider 2 examples. Radical on the right side of the first equation is already isolated. That's why it is not necessary to apply step 1 in either case. But in the second equation, one radical is to be isolated on any side of the equation. If we transpose the second radical from the left side to the right side, then we can have square root of x square minus 6x plus 9 is equal to 1 plus square root of x square minus 6x plus 6. Now the radical on the left side of this equation is isolated. Step 2. Exponentiate to eliminate the isolated radical. That is, raise each side of the equation to the power of the index of the radical and simplify. Let us consider 2 examples for making it clear. The isolated radical on the right side of the first equation is square root. That's why we are to square both sides of this equation for simplifying it. And the isolated radical on the right side of the second equation is cube root. That's why we have to cube both sides of this second equation for making it simple. Step 3. Repeat steps 1 and 2 if there is still radicals. Step 4. Solve the resulting equation. Step 5. Check all answers using the original equation. That is, the value or values of the variable should always be verified with the help of the original equation. Question 1. Solve. Square root of x minus 4 plus 2 is equal to square root of x plus 12. Solution. Square root of x minus 4 plus 2 is equal to square root of x plus 12. Radical on the right side of this equation is isolated, and the isolated radical is square root. That's why we have to square both sides of this equation. Squaring both sides of this equation, we get square root of x minus 4 whole square plus 2 into square root of x minus 4 into 2 plus 2 square is equal to square root of x plus 12 whole square. We have used the formula of a plus b whole square as a square plus twice ab plus b square on the left hand side of this equation. This equation implies that x minus 4 plus 4 into square root of x minus 4 plus 4 is equal to x plus 12. Cancelling square root and 2, we get x minus 4. 2 into 2 becomes 4. 2 square becomes 4. Cancelling square root and 2, we get x plus 12. Since minus 4 and plus 4 should be cancelled out, and we should isolate this radical, that's why we should transpose the term x from the left hand side to the right hand side, and doing so we get 4 square root of x minus 4 is equal to x plus 12 minus x. X and minus x should be cancelled out. Then this equation implies that 4 square root of x minus 4 is equal to 12. At this stage, we should always try to ensure whether there is a common factor or not. Since 4 is a common factor here, dividing both sides by 4, we get square root of x minus 4 is equal to 3. Again, square root of x minus 4 is isolated radical expression. That's why squaring both sides of this equation again, we get x minus 4 is equal to 9. Transposing the term 4 from the left hand side to the right hand side, we get x is equal to 9 plus 4. Therefore, x is equal to 13. Some of you may assume that this single value should not be verified, but this single value may not be the root of the given equation. That is, this single value may be an extraneous root of the given equation. In that case, the equation will be inconsistent. That's why, in spite of having the single value of the variable, we should always verify the value to the original equation. Verification. For x is equal to 13, left hand side is equal to square root of x minus 4 plus 2 is equal to square root of 13 minus 4 plus 2, as x is 13, is equal to square root of 9 plus 2, as 13 minus 4 is equal to 9, is equal to 3 plus 2 is equal to 5, and right hand side is equal to square root of x plus 12 is equal to square root of 13 plus 12 is equal to square root of 25 is equal to 5. Since left hand side and right hand side are each equal to 5, therefore for x is equal to 13, left hand side is equal to right hand side. Therefore, x is equal to 13 is the root of the given equation. Therefore, required solution x is equal to 13. Question 2. Solve square root of x square minus 6x plus 9 minus square root of x square minus 6x plus 6 is equal to 1. Solution square root of x square minus 6x plus 9 minus square root of x square minus 6x plus 6 is equal to 1. One radical is to be isolated on one side of this equation. Transposing the second radical from the left hand side to the right hand side, we get square root of x square minus 6x plus 9 is equal to 1 plus square root of x square minus 6x plus 6. X square minus 6x plus 6 is a common expression here. We may assume this common expression as a single symbol, but it is better not to assume here. Should assume in only one case. In this exercise, I will certainly discuss about it in my next class. However, the isolated radical is square root here. That's why we are to square both sides of this equation. Squaring both sides of this equation, we get square root of x square minus 6x plus 6 whole square is equal to 1 square plus 2 into 1 into square root of x square minus 6x plus 6 plus square root of x square minus 6x plus 6 whole square. This implies that x square minus 6x plus 9 is equal to 1 plus 2 into square root of x square minus 6x plus 6 plus x square minus 6x plus 6. Cancelling square root and 2, we get x square minus 6x plus 9. 1 square becomes 1. 2 into 1 is 2. Cancelling square root and 2, we get x square minus 6x plus 6. In order to isolate the radical, we should interchange all the terms of the right hand side and all the terms of the left hand side. And doing so, we get 1 plus 2 square root of x square minus 6x plus 6 plus x square minus 6x plus 6 is equal to x square minus 6x plus 9. This implies that 2 square root of x square minus 6x plus 6 is equal to x square minus 6x plus 9 minus x square plus 6x minus 7. Isolating the radical on the left side of the equation, we should transpose all other terms from the left hand side to the right hand side. X square and minus x square should be cancelled out. Minus 6x and 6x should be cancelled out. And 9 minus 7 is 2. That's why we can write 2 square root of x square minus 6x plus 6 is equal to 2. Since 2 is a common factor here, dividing both sides by 2, we get square root of x square minus 6x plus 6 is equal to 1. Since the radical on the left side of this equation is isolated, that's why Squaring again we get x square minus 6x plus 6 is equal to 1. This implies that x square minus 6x plus 6 minus 1 is equal to 0. This implies that x square minus 6x plus 5 is equal to 0. We have to factorize it by the process of middle terms. Since the product of first and last term is 5x square and 5x square can be expressed as the product of two factors minus x and minus 5x, whose algebraic sum is minus 6x. That's why this implies that x square minus x minus 5x plus 5 is equal to 0. Minus x and minus 5x becomes minus 6x, and their product is 5x square. Taking x common from the first two terms and minus 5 common from the last two terms, we get x into x minus 1 minus 5 into x minus 1 is equal to 0. Taking x minus 1 common again, we get x minus 1 into x minus 5 is equal to 0. Since the product of two factors is 0, therefore either x minus 1 is equal to 0, therefore x is equal to 1, or x minus 5 is equal to 0, therefore x is equal to 5. We should verify both the values of x with the original equation. Verification: for x is equal to 1, left hand side is equal to square root of x square minus 6x plus 9 minus square root of x square minus 6x plus 6 is equal to square root of 1 square minus 6 into 1 plus 9 minus square root of 1 square minus 6 into 1 plus 6, as x is 1, is equal to square root of 1 minus 6 plus 9 minus square root of 1 minus 6 plus 6. 1 plus 9 is equal to 10, 1 plus 6 is equal to 7. That's why E is equal to square root of 10 minus 6 minus square root of 7 minus 6. E is equal to square root of 4 minus square root of 1 is equal to 2 minus 1 is equal to 1 is equal to right hand side. Therefore, x is equal to 1 is the root of the given equation. Again, for x is equal to 5, left hand side is equal to square root of x square minus 6x plus 9 minus square root of x square minus 6x plus 6 is equal to square root of 5 square minus 6 into 5 plus 9 minus square root of 5 square minus 6 into 5 plus 6, as x is 5, is equal to square root of 25 minus 30 plus 9 minus square root of 25 minus 30 plus 6 is equal to square root of 34 minus 30 minus square root of 31 minus 30. 25 plus 9 is equal to 34. 25 plus 6 is equal to 31. Is equal to square root of 4 minus square root of 1 is equal to 2 minus 1 is equal to 1 is equal to right hand side. Therefore, x is equal to 5 is the root of the given equation. Therefore, required solution x is equal to 1, 5. Question 3, solve. 1 plus x whole to the power 1/3 plus 1 minus x whole to the power 1/3 is equal to 2 to the power 1/3. Solution: 1 plus x whole to the power 1/3 plus 1 minus x whole to the power 1/3 is equal to 2 to the power 1/3. This implies that cube root of 1 plus x plus cube root of 1 minus x is equal to cube root of 2. We name this equation as number 1. Since the radical on the right side of this equation is isolated and the isolated radical is cube root, that's why we have to cube both sides of this equation. Cubing both sides of this equation, we get cube root of 1 plus x whole cube plus cube root of 1 minus x whole cube plus 3 into cube root of 1 plus x into cube root of 1 minus x within first brackets cube root of 1 plus x plus cube root of 1 minus x is equal to cube root of 2 whole cube. We have used the formula of a plus b whole cube as a cube plus b cube plus thrice ab into a plus b. This equation implies that 1 plus x plus 1 minus x plus 3 into cube root of 1 plus x into cube root of 1 minus x into cube root of 2 is equal to 2. Cancelling cube root and 3, we get 1 plus x. Similarly, cancelling cube root and 3, we get 1 minus x. And putting this value as cube root of 2 here. X and minus x should be cancelled out. 1 plus 1 will become 2. That's why this equation implies that 2 plus 3 into cube root of 2 into cube root of 1 plus x into cube root of 1 minus x is equal to 2. 2 and 2 should be cancelled out from the both sides. Then we can write 3 into cube root of 2 into cube root of 1 plus x into cube root of 1 minus x is equal to 0. Since 3 into cube root of 2 can never be 0, so this equation implies that cube root of 1 plus x into cube root of 1 minus x is equal to 0. Since the isolated radical on the left hand side of this equation is cube root, that's why cubing both sides we get 1 plus x into 1 minus x is equal to 0. Since the product of 1 plus x and 1 minus x is equal to 0, therefore either a 1 plus x is equal to 0, therefore x is equal to minus 1, or 1 minus x is equal to 0, therefore x is equal to 1. In any odd radical, all the values of x are always true for the given equation. That's why in case of odd radical, we should write here x is equal to minus 1 and x is equal to 1 both satisfy the given equation. Therefore, required solution x is equal to minus 1, 1. But it is remarkable notice that for all even radicals, the value or values of x should always be verified with the original equation. The topic of the next class is radical equation part 2. If you have any query after participating in today's class activities, please let me know. Without any hesitation, I can assure you that it will of course be addressed with utmost importance. With this, I conclude here. Thanks. Best of luck.